There are still two main problems in the development of the H-tube. One of them, the digits are touching each other, which makes them glow together. And second is that after the sealing process, we get the digits oxidized, which makes it difficult to age and to achieve a uniform glow on the digits. And these past 2 weeks we are trying to make progress on both of these problems. As for the first problem, shorts between digits, we try to keep the stack of the digits as clean as possible. We want to preserve the beautiful 3D structure and the visual look of the nixie tube, so we want to avoid using any additional supports in between the digits. Instead, we go the way of tuning the font. Let's have a look at these small fine tunings that we made since the last time. By the way, big thanks to Tomáš Miller, who creates the font for us. So this is the font that we used previously for the test, and here we have a new one. The biggest problems comes from these long free-hanging elements. As you can see here, this side of the number 9 or number 6 is one long element without any support in the middle of the digit. This problem we are trying to solve by connecting these unsupported elements together so that we still keep the contours and the look of the digit. This is the new version where these two arcs were connected together here on the bottom, on the top, and also in the middle. And here in this place, additional support between the outer and inner contour was added. So this is the example how we're trying to increase the rigidity of the digits. Another example is digit 8, where on the previous version we had like this part separated from this part. So this is one long element, this is also one long element, and they could be sagging in different ways, making it short to digit 4, which is under the digit. And in the new version, Tom introduced the connection here. So let's have a closer look at the second problem, the digits oxidation. The source of the problems is the process when we seal the front window to the main envelope, because we need to increase the temperature on the edge to something like 1000 degrees of Celsius. And if there is any oxygen inside the tube, it will react with the stainless steel digits and it will turn them brown or yellow. So our current setup for sealing the front window to the envelope of the H-tube is to put the internal system with all the digits inside, then plug it from the back with a stopper with line of purging gas. The composition of this gas is 95% of nitrogen and 5% of hydrogen. The flow rate is roughly 5 liters per minute. I let the gas flow and displace the air from the inside, hoping that all the volume of the tube is filled with this purging gas. And then I start, so this takes roughly 1 minute, and then I start heating the edges of the window and of the envelope. Once I see that it's molten, I push the front window so that these edges stick together, and then I turn off the gas and continue heating up the edge until it's completely uniform, and then I cool it down with cooler flame. The reason why I need to turn off the gas is that if there is additional pressure inside and I heat the glass to higher temperature, it could cause a bubble. So the theory is that when we are sealing the window, when we have the high temperature here, we also have protective gas here, so no oxygen can get to the digits. As you can see, the digits, they turn golden, so somewhere there must be a source of the oxygen. So we're now going to do several tests that should tell us more about the problem. The intention here is to not find a method what we could use for the series production, but rather explore the problem from different angles and just to get more information about it. First test will be very simple. We will just increase the time we spend for purging the tube, and the idea here is that when we are doing the seal now, we still have some remaining oxygen from the air inside. If we let the gas to flow for a longer time here, we will eventually get rid of it and we might achieve better result. So this is test number 1. Já to zkusím dát. Tak, ježiš, to jsem tam jako tak, vypínám ten vákuum a teď to zkusíme sláním právě. every sealing attempt I recorded a video so that I can later see at what moment the digits gets oxidized. Unfortunately, this first video I set the camera incorrectly and the shutter speed is too slow, so the digits are blurred. As you can see, I just don't see any details. So the only thing that I found in this video is that at the end of the sealing process, when I started annealing with a large burner, the digits seem to be still silver here, and at the end of the annealing they are more golden. So because we know that at the end this tube had the digits slightly oxidized, they were light brown, I think it happened in the phase of annealing. Another possible problem that I see is that when we are heating this edge with the flame, the velocity of the gases in the flame are quite high, and I'm afraid that we are actually getting some oxygen from the flame because there is excess of oxygen. We are getting it inside, and then when I press the edge here, because we need to turn off the purging gas, we have some remaining oxygen from the flame inside the tube, and this later reacts with the digits. What we can do to get rid of the oxygen from the torch after we close the edges here is to drill a hole in the front window and let the purging gas flow inside just for a minute or so while we are keeping this at a moderate temperature. It could displace and remove all the oxygen from the tube, and then we can continue with the reheating and sealing these edges at higher temperature. So this is the second tube with the holes in the glass. I will skip the purging phase and I will go directly to the end of the sealing process. Here we have the shutter speed with the camera set to 1000 of a second, so we still can see the digits sharply. And so here is the end, and as you can see at the end of the sealing, when the edge is completely done, we can see that the digits are still silver. Like, I don't see any sign of oxidation on them. And now we start the annealing process. And I will skip a little bit, and you can see already here the digits are turning blue, especially at this part of number 4, which is close to the glass but not shielded by the wing of the anode cap. Here we can see it's completely blue. So in this case we saw clearly that the oxidation took place during the annealing process. The problem is that we didn't have the purging gas on during the annealing process, so the gas which is escaping from the torch could enter the tube and react with the digits. The reason why I had to close the purging gas was that it was creating overpressure inside, and the front windows started to lift from the envelope. You can see here. Here you can see how it's blowing. So this test was also not done well, but we can see that we can keep the digits shiny without oxidation during the sealing process, and then we need to focus more on the annealing. Another possible problem is that when we are flowing the purging gas from the back, it actually has to go between the glass and the anode cup, because the anode cup is a solid piece of metal, so it needs to go this way, and then it escapes here in the gap between the edge of the envelope and the front glass. And we are hoping that the gas from the back will displace also the gas in the front between the digits. But the reality might be that the gas is just going like this and whirling here and still leaving some air here, because it's not possible to get it through this gap. So better than this setup would be to introduce the gas from the front, but this is at the moment very difficult for us, so we will try one thing. We'll try to drill a hole here in the anode cup in the bottom and seal a glass pipe here, and later connect the purging gas here, so that we can here push the purging gas in. It will go here and then displace all this oxygen, all this air this way to the back of the tube. So we'll reverse the flow of the gas. We'll push it in the front and then it will go to the back.